Alright guys, so what we're trying to do is, hang on, what we're trying to do is use Scratch to make some artificial life. So let's begin by scrapping the Scratch cat for something simpler. Delete the old boy, and let's go with something greenish, and let's give him some eyes. There we go. And as you can see, it kind of cuts off the edges, so we'll need an invisible rectangle around it. Hang on. Place the rectangle there, and we'll remove fill and everything, and it should sort itself out. Let's make this an eye, and let's give him tiny pupil. Let's delete that one. There we go. Looks quite intelligent. So my plan is for this to be just a sprite and not have any proper code actually. It's just going to be like a stamp. We'll use this stamp function to draw our life, and we'll use this erase all each frame. So this, whatever uses this stamp thing needs to be on the sprite. So let's just try to make some code that goes somewhere and stamps, and then later on we'll add the we'll make more of these. Right, so let's try, click that one. Good, we have a stamp. So let's make some variables. Let's call them x and y, and we set these variables. For now we can set them to random numbers. Minus 200 for the x-axis and 160 for the y-axis, and we'll pop these in here. Alright, and we can use the flag. Good. But now we need to hide the mother sprite, and I think the mother sprite can be hidden at all times actually. Yeah, it can stamp even though it's hidden, so we don't need to show it each time. Alright, so this is fine. We have an image. It's like a clone, but it's we can't move it. And the idea is that Scratch is the maximum of 300 clones, but it doesn't have a maximum when it comes to these, right? So we could in principle repeat this. Let's do it 300 times. We'll erase everything up here. Let's do 1,000. Let's change the size, and yeah, we need to put these in here. Alright, so there we go. Yeah, great. this wouldn't go because it takes too long. So we'll make a block called draw, and we'll run it without screen refresh, and we'll put this in here. So well, that's not good. It's supposed to be instant. Alright, hang on. Let's see if we can see if this speeds it up. Without screen refresh. It's a bit strange. But of course, if I use turbo mode, it works. Let's see if this works better. Yeah, all right. So the repeat function, this should of course work, but this adds some delay. So it needs to be in here. And I guess we can put these back as well. Alright, good. And now it's time to make these not random, but part of some sort of a list of cells. These are our cells. So let's add a list. Not a variable, but a list. So let's call it cells. And for now we can just add a single cell. Let's give it an X and a Y, and we should be able to do this. Alright, there we go. It looks a bit silly. I wonder why. Let's give it the full size. Kind of has that. Oh, there's 1,000 of them on top of each other. That's why. Yeah. Right, for now. Good. Alright, so this is the cell now. It has its personality in these two parts of the list. So we can add more. We can add more of these. So we can add 30, and yeah, we've got 30 of them, right? But this only draws the first one, so we'll need to make a loop to iterate through the cells. This of course, well, the hide part. Well, I'm sorry. We need to keep this inside the cell sprite because it uses the draw function, I believe. Yeah. Alright, let's loop this by repeating it the number of times the length divided by the number of values associated with each cell. So that would be in this case 2, and the length of the array, the list. and we can't be using item 1 and item 2. We need to use the index. We'll just call that I. We set the variable to 0. We change I by 1, and we can do that after we've stamped, and so the x value will be 0 plus 1. Plus I, of course, I'm sorry, plus item 1, no, hang on, item I plus 1. There you go. There we go. And this one will be item I plus 2. Right, so the first cell I will be 0, and so the index will be 0, and we add 1 because yeah, I prefer working with 0 indexed lists, but this is not 0 indexed, so it's just a habit, I guess. Alright, so there we go, we've got 30 cells. Now this is a magic number, and this is wrong because we're supposed to be skipping 2. Yeah, there we go. And this is a magic number, so let's make that a variable. Cell, let's see, attributes count, and let's just set that to 2 for now. There we go. There we go. Yeah, should work the same like this one, this one, and this one. Alright, so let's try to push it by having this be a variable and increase that as well. Number of cells. We can set that to, let's do 1,000. There we go. And we didn't even use the turbo speed, right? Alright, let's make them smaller. Yeah. Let's try to push it even more. 10,000 cells. But the length of this list cannot be larger than, I think, 50,000. So let's try the maximum amount. Yeah, well, now it's a bit laggy. Yeah, but it still works. Alright, but of course we'll need to add more stuff, and first of all I think we need to add movement. So we need to add a velocity velocity in the x direction. Let's set the velocity. Well, I'd like to keep that down here so that we can have a nice we need to have some sort of plan, you know, to keep the indexes correct. So the speed needs to be a smaller number, as it will be like if Scratch can do its full speed, it will render at 30 frames per second. So if we had have the speed even like 10 would make it move out of the screen in less than a second. So we need to lower this, and we need to divide by something. So we need to divide by, say we divide by 100. There we go. And now it's a matter of just incrementing this one. And the velocity for now should change the x value before it moves. Which is a bit tricky. But we can do that, and still keep the order if we do this, which is a bit of a hack. And then after it's moved, then we'll change its x value based on its velocity, which means that next turn it will have updated its x value when we draw it. Yeah, so we don't need to move that to the top. And this is a bit finicky, so we need to replace the x value, which is this one, with this one plus this one. No, with, oh, hang on, we need to replace it, the x value, with the x value plus the velocity value, which is there. But we have already saved these, so of course we can just use those right away. X value plus velocity x, and that's much more simple. There we go. Abstraction is great. Alright, and let's do that down here before we change the eye, of course. Alright, so yeah, that's a bit weird. Well, alright. Anyway, let's try to loop the drawing function, which is, it's drawing and updating at the same time. So I think if we do this and so this should be an update function. It doesn't really matter. Just it's draw and update it at the same time. All right. Well, something's not correct. So this is a hugely negative value, and yeah, it's too long. Oh, let's Yeah, the count has gone up. We've got 3 now. There we go, and let's do 10. Yeah. Alright, so there's huge X values. Place item I plus 1 of cells with X. We haven't defined X yet. Yeah, so we can't have it there, we need to have it there. There we go. Yeah. Alright. So we got our cells. Let's try to do 1,000. Alright, and now we should be able to draw these, and they should move. Yeah, they do. They do, great. But we need to clear we need to erase all. We need to put that at the over there, I think. Yeah, great. All right, they're moving and they're getting stuck at either end, right? Their X values are either going very negative or very positive, and I plan on using the donut function, the donut layout, right? That if you go too much north, you'll end up in the south, and too much to the right, you'll end up at the left part of the screen. And that code could be in a separate function, I guess. So let's call that check boundaries, and we need to check whether or not any of these are to the right or to the left for now, and if they've gone past 240 or negative 240, that means that their velocity is pulling them in that direction, because nothing can push it, right? So if these could push each other, they could be pushed towards somewhere they aren't heading, but currently that's not possible. So let's just loop through the array and to check whether or not they're too far right or too far left. So we're going to use some of the same structure. We're going to set I to 0. We're going to repeat it for the length of cells. Hang on, we're going to repeat it for the amount of cells divided by cells attributes, and we're only interested in the X value, and we'll do an so if we do this, if the X value is more than 240, it should go to negative 240, right? So then we'll replace the item I plus 1 with negative 240. And which means that if we do the same for Y in the next part, it should not move it because it's checking if it's less than, not exactly, minus 240, which means we don't need to add any more code or an else if with a nested if inside. And this is this should work. Yeah, we can do it in a fancier way, but it shouldn't be necessary. Let's see. No, because we aren't running the code. Let's check boundaries and then draw. No, because we are not incrementing I. So let's increment I by cell attributes count. There we go. Alright, there we go. Marvelous. Hang on. It seems that these work, but these get stuck. Alright, so let's see. They get stuck at minus. Yeah, alright, so if. Hang on. If x is less than minus 240, it's, yeah, so it is less than 240. And we are replacing it with negative. There we go. Alright. Alright, so the final thing we'll do today is to make them face the way their velocity is, and that could be a bit complex when we add the y axis, but for now it's pretty simple, so let's keep it simple. We can just flip them. Hang on. We can't be. We should be. If we could flip them up here, that would be great. But we can't because they're not clones. They're stamps. So I'll have to flip them. I think flipping adds a bit of performance issues. But let's just try. We need to make set rotation style left right, and we need to rotate pointing direction, so it's pointing direction 90 or negative 90, and if I think we need to zoom in. If anyone's watching this on a cell phone, they won't be able to see anything. So if the the velocity is more than 0, they are heading right. So this should be good. I don't know where the best place to put that is. There we go. Hang on, let's take a look. So they're all going the wrong way. All right. Velocity is more than 0, then they should point to the right. And they're not. Well, we haven't set velocity yet, but so the velocity is -0.1. So in this case, it's -0.1. It's bigger than. It's less than 0. So it should point in that direction. I have no idea. But whatever's wrong, this will fix it. No, it won't. No, it won't. Then point is just before we stamp. They're all going backwards still. Now it's working. Yeah, fine. I have no idea. Yeah, because if I did it before I set velocity, this was the velocity of the previous cell. Yeah, of course, we can't use any of these variables above them. It's not the same cell. There we go. Let's just crank up the speed. Yeah. Alright. And we can add another 0. And yeah. Let's just see if removing this has any effect. Alright, so let's add that back in. Alright, so negligible effect. And let's try to convert these to bitmaps. I think let's keep an eye on that guy. Minor. Yeah, good. So we've got 10,000 cells. That's a bit more than the 300 clones you can do if you're using clones. So we'll have to add the y-axis and some other attributes later. Right. See you guys.